So in this worksheet, I give you guys 4 different velocity graphs, and 2 of them have a positive VO, and one of them has a positive slope, the other is a negative slope. And then we have the corresponding ones that start with a negative VO. Now, in some ways these graphs look pretty similar, but it turns out they're actually pretty different when you start to think of what the position time graph, and therefore what it actually looks like to move this way, and what the acceleration time graph looks like. So what I want to do is just kind of walk through these, and I'm going to act out the different motions, and hopefully by the end of this you'll sort of have an idea of some of the logic it takes to go between these different graphs. So for the first one, it says I have a positive initial velocity and it gets more and more positive. So what should that mean for the position time graph? Let's take a look at the motion.
I put my origin right here. I'm calling that way positive. I'm calling that way negative. So one thing you're not seeing on any of these graphs is position. I can start wherever I want. So this says it's a positive initial velocity, and the absolute value, the magnitude of that velocity is increasing. So that's actually a pretty simple graph. I start going in the positive direction, and I speed up.
So in this first one, we're starting off with a positive velocity and it's increasing. So basically, that means our slope at the beginning here needs to be positive, and it needs to be getting bigger and bigger and bigger. The slope of a velocity time graph is the acceleration, and in this case, the acceleration is always positive, and the slope is not changing. So the acceleration graph should simply be a positive horizontal line. In this case, we have velocity. It starts out positive and decreases, and eventually goes to 0. Then it actually increases in the opposite direction. So this describes an object that's slowing down, stopping, and then switching direction and getting faster. Let's take a look at what that motion looks like.
How about this one? Positive initial velocity, but a negative slope. And what does that intercept mean? What does it mean to cross the axis? Well, it means my velocities will be positive, but they'll be decreasing. The speed will be slowing down. When I cross the axis, the speed will be 0. So that means I stop. And then as they trend to larger absolute values in the negative direction, that means I go backwards. So something like this.
Here's its position time graph. We need to start with something that has a positive slope that decreases to 0. And basically this 0 velocity corresponds to that 0 slope. Then we need to get steeper in the negative direction. So something like that. As far as the acceleration graph goes, notice it has a constant negative slope. Slope on a velocity time graph is the acceleration, so that means we have a constant horizontal negative acceleration. In this case, we start out with a negative velocity. The object is slowing down to 0, and then we have an increasing positive velocity. So this is kind of like the opposite of the graph up here. Let's take a look at what that motion looks like.
So maybe something like this.
So here I am starting with a negative slope. That slope is leveling off. And this corresponds to the place I've stopped, right here. Notice that the fact I've crossed the x-axis doesn't matter at all. And now we end up with a positive velocity. And it's increasing like that. We have a constant positive slope here. That means we have a constant positive acceleration. So basically, when you see the velocity graph cross the x-axis, that corresponds to a change in direction. And on the position time graph, that corresponds to either the minimum or the maximum, the place where we have zero slope. All right, for completeness, let's do number 4. We start off with a negative velocity, and it just gets more negative.
I don't know if I can do that without hurting myself.
So that means we have a negative initial velocity, and it just gets steeper and steeper and steeper. This is a constant negative slope, so it's a constant negative acceleration. And that's it. So we started with these velocity graphs, and we worked our way to the position graph and to the acceleration graph. Key thing to remember is that the slope on a position graph at any given time, that slope, if you plot it, gives a velocity graph. If you plot the slope of a velocity graph as time passes, that gives you an acceleration graph. So we should be able to move in both directions. We have an increasing velocity here. This increasing slope shows that increasing velocity. So we want to practice moving between these three graphs.